Hi, my name is Eloise. Welcome to another lesson in our series on investigating geometry. Once again, Cindy and Gerard are on hand to help us with our investigations. Hi guys.
Hi Louise. Hi everyone.
Hello.
We're going to look at ways of proving theorems about quadrilaterals. Do you think you're ready for this?
I'm ready. That's what I'm here for.
Good, because in today's lesson, we'll also be using transformation and Euclidean geometry to investigate some of the properties of kites. By the end of this lesson, you should be able to use transformation geometry to prove a conjecture about kites and plan and write a paragraph proof. To start things off, let's look at this problem. Given parallelogram A, B, C, D, we are going to prove that A is equal to 110 degrees. There are several ways to prove this. Here's one. In any parallelogram A, B, C, D, the opposite sides are parallel. This is one of the properties that define what a parallelogram is. So we can say that AD is parallel to BC. We know that the co-interior angles on parallel lines add up to 180 degrees. So A plus B is 180 degrees. We know B is 70 degrees, so A must be 110 degrees. That was a pretty easy proof, wasn't it? But the statement was about one specific case using a given angle size. Sometimes you need to prove something is true for all cases, and that's what we're going to do with a kite. Are you ready?
Ready.
Okay. What do you know about this kite? What properties does it have? Remember, when we classified kites, we saw that they had two pairs of adjacent sides equal. But can you use this property to make a conjecture about the angles of any kite?
What's a conjecture again?
Good question. A conjecture is a statement that appears to be true, but hasn't been proved to be true yet.
Well, I think the opposite angles of a kite could be equal.
That could be our conjecture.
I suppose it can.
So our conjecture is the opposite angles of a kite are equal.
Okay, to see if your conjecture is true, you need to find a way to prove it.
We can measure lots of opposite angles of kites.
But I don't think that proof can work for all of them.
You're right, Cindy. If you find that the opposite angles are equal in every kite you measure, it doesn't mean that you have proved your conjecture for any kite. There's always the chance you'll find a kite where it isn't true. What you need is a proof that will work for any kite.
I think we should start off with the definition for the kite.
Well, if I remember correctly, a kite is a quadrilateral with two pairs of adjacent sides equal.
So for any kite, we can say these sides are equal. And so are these sides.
You're on the right track. A definition is a good starting point. It helps us to have a common understanding of what we know about the kite.
Okay, let's label our kite K-I-T-E. This will allow us to use angle and side names from now on. So our conjecture is that the opposite angles of a kite are equal, right?
Right.
So we need to prove that angle K is equal to angle T, and angle I is equal to angle E.
But that means we're trying to prove two things.
So let's split the proof into two parts.
Good thinking, Cindy. Looking at each pair of angles separately is a good systematic or step-by-step approach. So which angle are you going to look at first?
I think we'll start at the angles I and E. I must say, the angle at I looks much bigger than the angle at E. They can't be equal, surely.
They don't look the same. And if you can find one example of a kite where the angles aren't equal, that should be enough to disprove the conjecture of the angles of a kite.
Let's measure them just to be sure. Okay, this one is 50 degrees. That one is 60 degrees.
Yes, your conjecture about the opposite angles of a kite is not true for these two angles. We may conclude this because the angles are not equal. This is called a counterexample. A counterexample is when you show that something is wrong or not true by showing an example where it doesn't work. In maths, drawing or showing a counterexample is a valid way of disproving a conjecture. And you only need one counterexample to prove something's not true. Well done! But what about the other two angles? Can you prove that they are equal for any kite?
I think one way to make a kite is if we use a scaling triangle and reflect it onto one of its sides. I can trace over it like this, then reflect it over this line, and then trace over where the triangle is now. That's it. We have a kite with one diagonal drawn in. This side is equal to this side. We know that because it is the same side. It's just in a different place.
But check here. This angle is a reflection of this angle. So these two angles are definitely equal.
Well done! Did you notice that Cindy and Gerard used transformation geometry? By reflecting a triangle, they showed that one pair of opposite angles of a kite is equal.
And that's exactly what we wanted to prove, that angle K equals angle T.
What Cindy and Gerard didn't realize was that by thinking through their proof, they were actually planning their proof. All that's left now is for them to write their proof down.
Let me see. Take a scaling triangle, KIE, and reflect it over the line IE to create another triangle, TIE. Together, the triangles make a kite, KITE. The angles at T is a reflection of the angle at K. So the angles T and K are equal. So these opposite angles of the kite are equal.
Great stuff, Cindy. All you did was simply describe each step of the proof using sentences. This is called a paragraph proof. Once we have proved a conjecture about the properties of a shape to be true using sound logic, we can call this a theorem. A theorem is a statement or conjecture that has been proven to be true. If you draw conclusions from true premises using sound logical steps, then you have used deductive reasoning. Theorems are based on this kind of reasoning. Conclusions that are made by deductive reasoning do not rely on ideas only or on finding many examples. In today's lesson, we saw that you can solve a geometry problem that is about a specific case. We also saw that you can prove a conjecture to be true using the properties of a given shape. Although we used transformation geometry for this proof, Euclidean and coordinate geometry proofs work just as well. Then finally, we saw that you can write your proof in sentences to make a paragraph proof. Now it is your turn to try out these ideas. Prove or disprove the following conjecture. The diagonals of a kite bisect the angles of the kite. Plan your proof and write it in a paragraph. In our next lesson, we will look at a different way to write down a proof using a flow chart. Until then, it's goodbye from us all.